Okay, Assalamualaikum warahmatullahi wabarakatuh. So we continue on the AC circuit analysis, but more towards on the complex numbers. So for example, we have this AC circuit, we have AC, okay, and we have resistor. I think I draw again. Okay, we have this AC circuit, voltage source, and then we have a resistor, the value is 10 ohm, and we have component which is L is equal to 0.2 Henry, and we have capacitor which is the capacitor is maybe around 10 microfarad, and okay, and this circuit, the frequency of this circuit is maybe 50 hertz. Okay, and okay, sorry, not 50 hertz. Okay, let's say that we have the voltage source here, Vs omega t. So Vs omega t is actually 50 sine 20t, okay, plus 10 degrees, for example. Okay, how can we actually solve this? So as you can see, this is actually a single loop circuit. So meaning that when you have a single loop basic, so it is easier to solve using basic Ohm's law. Okay, but because this is AC circuit, so you need to remember that we have what I call a new component, which is the inductor and also the capacitor. So we have this current, which is the current is actually an AC current, and we need to have you know the relationship between the current, voltage of the inductor here. So this is actually a voltage drop, and then this is your voltage drop across the inductor, and this is the voltage drop across the capacitor. Okay, so for the inductor, the voltage drop across the inductor can be calculated based on this equation. L is equal to D, and then the current that flow through the inductor over dt. Okay, so this is the inductor, the value of the voltage across the inductor. Okay, and VC. So VC is quite challenging. So actually the VC is actually okay. Actually VC is quite challenging. So actually VC we need to actually start from the current. So the current IC, the current that flow inside the capacitor. Okay, so this one also need to be VL omega t. Okay. Okay, this one should be C multiplied with dV across the capacitor, the voltage across the capacitor over dt, or in other words, you can have your Vc omega t is actually 1 over C and the integration of ICT. Okay. So this is actually the voltage of the inductor and also the voltage across the capacitor. So you can see it is quite very complicated, okay? Because when we try to solve this by using basic Ohm's law, so this is the KVL inside this one. So actually we start with this negative positive. So meaning that you have a negative Vs omega t plus VR omega t plus VL omega t plus VC omega t is equal to 0. So you can actually, meaning that you need to write down this equation. So Vs is actually transferred here. So you will have 50 sine 20t plus 10 is equal to VR, which is 10 ohm multiplied with IT plus L, which is 0.2 Henry, 0.2 multiplied with DI dt, okay, plus VC, which is I 1 over C, IC. Okay, so this is quite okay. So as you can see, it's quite complicated. Okay, it's quite complicated and it's not very easy to solve. So, and actually during our previous class, I said that this AC circuit analysis can be can be done in easier way by representing this circuit into what we call phasor form. Okay, so let's look on how to actually we solve this by using a phasor form. Okay, so first of all, what we need to do is actually to represent the inductor and capacitor as a reactance. Okay, so this is your R, 10 ohm, and this is your inductor, this is your capacitor, and your voltage source. Okay, so positive. So since the voltage source, which is this is not omega t actually, we can actually put as a t. Okay, so I don't quite remember. Maybe 30. Okay, 30 sine 20 plus 30 degrees. Okay, so this one you can represent into a polar form by representing only the magnitude and the phase, which is 30 with an angle of positive 30 degrees. So this is Vs. So I can write down in a polar form, so 30 with angle of 30 degrees. So this is my voltage source. And the resistor is a constant value, which is 10 ohm. And this inductor, you need to actually converted it into what we call XL. The X, which is, we call this one is a reactance. Okay, so we have this one, positive JXL, and the capacitor is negative JXC. Okay, so what is XL and XC? So X is actually a reactance. So positive JXL is actually referring to positive J omega L, and negative JXC is actually negative J 1 over omega C. Clear? So what is omega? So omega is actually 2 pi F. And what is your F? F is actually, or it's actually already been given. For example, we have the voltage source right now, which is 30 sine 20t, right? 20t plus 30 degrees. So actually, this one is your omega. Okay, so you can actually write down your omega as a value of 20. So this is also same. So 20. So if your R is 0.2 Henry, so meaning that positive J 20 multiplied with 0.2, So you should have positive J 20 multiplied 0.2, which is positive J 4 ohm. Okay, and your XC, the reactance of the capacitor, is actually negative J 1/20 multiplied with 10 microfarad, where you can have is equal to 20 multiplied 10 to 6 is actually negative J 5,000 ohm. Okay, so this one you can actually replace this as a positive J 4 ohm, and this one is negative J 5,000. So right now your resistance and reactance are all in ohms unit, and this is your current flow I/O. Okay, so this is, you need to remember that right now we are actually in a phasor form. Okay, so don't have IT here, so meaning that from here you can actually using a basic Ohm's law, you can calculate your which is this one is a Vs is equal to 10I plus J4I negative J 5,000I. Okay, and then your Vs is 30 degrees. So this one 10I plus J, so negative 5,000 over is actually for negative, so this one is negative, should be negative J 4,996I. Okay, or we can actually write down 30 to 30 degrees. So this one will be 4,996 I. So from here you can calculate your I. So your I should be 30 degrees over 10 minus J 4,996. Okay, so your I should be, by using your calculator, is actually okay over 10 minus 4,996. Okay, should be 6 milli, and then the angle is 119.9 degrees ampere, or actually this one 0.006 angle 119.9 ampere. Okay, so if you want to actually write down in terms of time domain, so this one you can write down. So I t is actually 0.006 sine 20t plus 119.9 degrees. Okay, so that's all for the basic Ohm's law.